to Math Snacks. I'd like you to meet Miss Glovely. And my name is Miss Wonderful. Today we're going to talk about money. I love money. Wouldn't you like to have some money, Miss Glovely?
Oh, somewhere between $1 million and $1 billion would be nice.
Between $1 million and $1 billion, that's a lot of money to be thinking about.
Yes, that's really big numbers.
Well, sometimes a number line can help us think about big numbers. Why don't, Miss Glovely, you draw a number line on the board, and we'll talk about $1 million and $1 billion and even $1 trillion.
$1 trillion? I can't even imagine how big $1 trillion would be.
Put $1 million on this end of the number line.
Would you like that in numerals or would you like that in words, Miss Wonderful?
Let's put that in words.
Okay, 1 million.
And let's put 1 trillion, which is a real big number, on this side of the number line.
Alrighty. There we go, kind of, sort of.
Okay, so if we have $1 million and we have 1 trillion, I wonder where $1 billion goes. What do you think about that, Miss Glovely?
I'm not sure. Where do you think it would go, Miss Wonderful?
I think it must go smack dab in the middle.
Okay, we'll put a mark there, and you think that's where 1 billion goes.
I think 1 billion must go right here.
Well, that kind of seems to make sense because write them in numerals. Write what they look like in numerals. 1 million would be 1 followed by 6 zeros. And $1 billion would be a 1 followed by 9 zeros. And $1 trillion then would have to be a 1 followed by...
Let me guess.
Okay.
12 zeros?
I think you're right.
I saw a pattern.
Yeah.
Math is all about patterning.
So it seems to be logical that 1 billion might fall right halfway between because 6 zeros, 9 zeros, 12 zeros.
Yeah, that makes sense to me.
Okay. Now how could we prove or disprove that that's correct?
Maybe working with a smaller number might help us think about it.
Okay. What would you like to do?
Well, let's try a number line. And let's go with some really small numbers. Let's go with another pattern.
Okay.
Let's go with 1 and 100.
So we're going to, if we follow the same pattern, we're going to place 10 on the number line. Uh-oh.
Uh-oh, we've got a problem. Because 10 doesn't go in the middle of this number line, because 50 would go there.
That's right. So maybe we have a problem with this number line. What are we going to do now?
Well, let's think. Where does 10 go on this number line? It goes somewhere about here.
Mm-hmm.
So if we put 10 here, I know because it's a pattern 0, 1, 0, 2 zeros, kind of like we did 6, 9, 12 here. Even though it's another place value, we're taking 10 of these, and that unit is much smaller. But 10, the size of 10 is a much bigger amount. So 10 tens
would have to fit between 1 and 100.
Right.
Okay.
So I think because they get bigger. The unit gets bigger, I think, is why this doesn't work. This isn't actually 1 billion.
What would really fit halfway between 1 million and 1 trillion? Approximately. Do you think?
I don't know.
I wonder how we could figure that out.
I would have to say if I look at this pattern, it must be 500 billion?
Yes, I think that would be approximately correct. Be closer.
500 billion, and I write that like this. Wow, that's a big number and a lot of zeros.
Wait a minute. You have the right number of zeros there? 500 billion. Yep, you're right.
369.
Okay, gotcha.
Okay. So that really is like 1/500th of that. So it's like clear down here.
Right, it would be almost touching the 1 million.
Oh my goodness, clear down here?
Or maybe even closer.
My goodness. Well, I'm going to put now 1 billion here.
Okay. to give us the idea that it is
Really?
much closer to a million than halfway or to the trillion.
I'm going to put a sad face there.
Okay.
Because I wasn't thinking very clearly at all on that, Miss Glovely.
Well, but that's how we figure these things out. Sometimes it helps to work with a simpler problem.
Okay. Can I write that here?
Sure.
Solve using a simpler. Sometimes I was told the reason it's hard to understand problems is because we can't relate to this size of number. It's that we need to relate it to something that is more concrete for us. Mm-hmm. Do you have any ideas of how we could be thinking about this differently?
Well, you know, we actually have come up with an example that would be more concrete and have people be able to understand the relative magnitude of numbers, because that's what this is. When these numbers are this large, we're looking at their magnitude or their size, their gigantic size. So one example is to take a $10,000 bill, which is not
Whoa, $10,000! I'm going shopping.
No, you're not going shopping with that $10,000 bill, because they don't really make those, Miss Wonderful. But if they did, and you put a stack of $10,000 bills that was 4 inches high, and we just happen to have an example of 4 inches high. And if you don't,
wow.
This doesn't look like it's 4 inches, but amazingly enough, that is approximately 4 inches. So if we had a stack that was that tall,
that'd be a lot of money.
You know how much money that would be, Miss Wonderful?
I bet it's $1 trillion.
No, but it is one of those numbers on the number line.
I bet it's $1 million.
That would be $1 million.
Now that would be some shopping money.
That would be shopping money for you. That's correct. That would be my children's college account. But okay. And then if we wanted to see what 1 billion of those would be,
this is $1 million. If this was all money, which it's not.
I know. Sorry.
We'd have $1 billion here.
No, that would be $1 million.
$1 million. Man, I'll get it right yet.
But if we took that stack and continued to place $10,000 bills in stacks like that, and then stretched them out for the length of a city block,
wow,
then you'd be in hog heaven. It would be at $1 billion.
I could buy all kinds of math manipulatives with that.
Oh, you are sad. But if you wanted to go clear to the $1 trillion, we have to bring out the map of our lovely state and go from Hutchinson, which is right about here. Oh, she's going to zoom in on me. Okay, but I got to go this way. Hutchinson's right about here, and we would have to go just past Wichita, Kansas, to get that same stack of bills stretched long enough to include $1 trillion. So
how many miles is that?
That's about 62 miles of bills, $10,000 bills, if they made $10,000 bills. So that kind of gives you an idea of the relative magnitude of large numbers, from a 4-inch stack at $1 million to a city block, which is $1 billion, to 62 miles would be $1 trillion.
So we've got 4 inches,
right,
to a city block,
right,
all the way down to here would be equal to 62 miles of $10,000 bills.
And that gives you an idea of the size of those numbers.
Wow. Well, I am so glad you were able to help me miss this.
And I'm so glad I could be here today with you, Miss Wonderful.
Join us for another session of Math Snacks later. Bye.
Bye.